Welcome to Homework Lib.
This is chapter 35, problem number 8. We are given the slit distance as 0.45 millimeters and the distance from the screen as 75 centimeters and lambda to be 500 nanometers. And we're trying to calculate the distance between the second and the third dark lines of the interference pattern. So dark lines, as you know, means destructive interference going on. So d sine theta equals m1/2 times lambda is going to be our equation if we want to know where exactly the second and the third dark lines are located, right? So first we need to get that information. So for each one of them, sine theta is going to be equal to m plus 1/2 lambda divided by d, right? So second dark line corresponds to m value 1, and the third one would be m equals 2. So we're going to plug these in and calculate our thetas. So sine theta 1 is going to be 1 plus 1/2 times 500 times 10 to the power of negative 9 meters divided by the slit distance, 0.45 times 10 to the power of negative 3 meters. So from here, sine theta 1 is going to be 1.66 times 10 to the power of negative 3. And if we were to calculate sine theta 2, it would be 2 plus 1/2 and 500 times 10 to the power of negative 9 meters divided by 0.45 times 10 to the power of negative 3 meters. So then it's going to come out to be 2.77 times 10 to the power of negative 3. Now, as we know, theta 1 and theta 2 are very small. So we're going to do an approximation here. We're going to say for every theta that is really small, theta is approximately whatever sine theta is, and then that is approximately is going to be the tangent of that angle if the angle is small enough. So now we want to know the distance between the second and the third dark line on the interference pattern. In order to figure that out, we need to know the distance of, let's say, of the second dark line from the center of the screen. So y1 is going to be equal to r times tangent theta 1, and y2 is going to be r tangent theta 2. And we want to know the difference, right? So y1 minus y2 minus y1. So it's going to be r tangent theta 2 minus r tangent theta 1. Then this is going to be equal to r tangent theta 2 minus tangent theta 1. As you know, r is 75 centimeters, so convert that to meters. And then from the approximation, a tangent theta 2, you can use this tangent theta 2 is going to be same as sine theta 2. And same thing goes for tangent theta 1, sine theta 1. So we can plug in the values that we calculated previously. It's going to be 2.77 times 10 to the power of negative 3 minus 1.66 times 10 to the power of negative 3. So if we do the algebra here, what we get is 8.3 times 10 to the power of negative 4 meters for the distance between the second and the third dark line of the interference pattern.